Multi-core processing is really useful if you need to compute some big operation that would take your computer a really long time to do. What I'm showing here on the top is our terminal, and on the bottom is kind of some system information for my computer. I'm on a computer with 6 cores, so you can see 1, 2, 3, 4, 5, 6. Here it's telling me how much of my RAM, my memory I'm using. And you'll see what happens as we run this process. To do this easily in R, you first need to install and load the for each package, as well as the do MC package. That's do multicore. And then you want to say how many of your cores you want to use. So on a laptop you probably have between 1 and 4, most likely 2, and on a desktop you might have up to 6 or even 8. And so I'm going to say I want to use 5 cores on this process. I'm going to make some kind of placeholder data, and I'm going to run a pretty big operation. So first I'm making a matrix just filled with nothing, and it's going to be 1,000 rows and 1,000 columns. And so that matrix looks like that, filled with nothing. And now I'm going to run this kind of long operation that is for each row. I need to take a random normal sample. I'm going to sample it down to 0.63. I'm going to do it with replacement. Then I'm going to sample from that and populate each column with that row, etc. It's a meaningless thing, but it just takes kind of a long time. And I've also wrapped that in a system time function to get the time on it. So if I run that, what I really want you to pay attention to is on the bottom here, what happens to the cores. You should see now I've got 5 cores all going near 100%, and so what that means is my computer is working all together, all 5 of these cores. The user time, the amount of processing time, was 26 seconds, but because I did it with many cores, the elapsed time was only 7.896 seconds. So usually user time is always going to be less than elapsed time, but because we did multi-core processing, we saved a lot of time. And this